What is step 3?
Create another column called cumulative frequency.
So we have to create another column called cumulative frequency, and I've already created the column. Okay, cumulative, because I copied this from the explanation and I just erased certain things because I'm going to demonstrate it again. Cumulative frequency. We have cumulative frequencies already. Cumulate means to add. So therefore now we're starting with 14. Okay, so just carry forward that 14. Okay, we carry 14. Now if we look at the instructions, it says immediately after you surpass the location of the median. As soon as you go beyond the location of the median, you stop. Okay, make sure you stop. The location we calculated to be 15.5. This is 14. So we cannot stop yet. Can somebody please tell me what comes under 14? Make a wild guess. Let me know what you're thinking. Anybody? What comes under 14? For the person that just joined in, we're doing number 10, part F, the median for interval distribution. We're on step number 3 and 4. Step number 4, we are accumulating the frequency. And step number 5 say immediately after you surpass the location, you have to stop. So we haven't reached step number 5 yet. And this would be the median interval. Where you stop would be the median interval. Okay? So we haven't reached the median interval yet. So step number 4 and 5 is happening. Can somebody please tell me what comes under 14?
19.
19. 14 plus 5. So you carry down that 14 and you add it to the 5. And that will give us 19. So we have to stop because we have surpassed the location of 15.5. Okay. So we must stop. Okay. And then where we stop now is called the median interval. So our median interval is 20 to 25. Okay, that's the median interval. Okay, 20 to 25 is the median interval. So that's step number 4 and 5. So we can write here, therefore, the median interval is 20 to 25. The median interval is 20 to 25 years. Okay, let's move on to step number 6 now. It says apply the following formula. So let's copy this to estimate the median. All right, because some information got lost whilst this table was constructed. So I repeat, some information got lost while the interval distribution was constructed. For example, these are 30 individuals, 30 students. 14 of them are between 15 and 20. We do not know, and we can never know unless we haven't got the original raw data, what the actual values were or are. All we know, 14 of them are between 15 and 20. Some are 16, some are 17, some are 18. Sometimes none of them are 18. So this is why it's called an estimation. because some information got lost whilst the data was being organized. And that's what happens when you are managing data. When you're doing a research and you start to analyze the data, whilst in the process of analyzing the data, some information get lost along the way, errors are created. So in the final say, we're always talking about estimation approximately. Okay, so that's why I say estimate the median using this formula. For the stem and leaf, it's not estimate because we have the raw values there already. That's one of the advantages of the stem and leaf. But then if you have 500 values, you can make a stem and leaf with 500 values. You have to group it up. Okay, and whilst doing that, some information get lost. Okay, so we have to substitute into this formula. Now to substitute into this formula, let us list our values. The lower boundary of the median interval. What is the lower boundary of the median interval? Let's list our values. Anybody? We need to find the lower boundary.
19.5.
Say that again. 19.5.
19.5.
You see, so that's why I need to know what you're thinking. You are thinking 19.5, and I know why. Because you are custom with intervals whereby you have 15 to 19 and then 20 to 24. I know that type of
Oh,
interval, but this is not the case here. So that is why I need you all to participate so I can know what you're thinking. So I know that type of interval. This is not the case. Here is 15 to 20 and then 20 to 25. So the lower boundary is the same as the upper boundary of each other, if you understand what I'm saying.
yes, sir.
Right. So the lower boundary there is actually 20. And for